Very good morning to all. So we will continue with the sorting techniques which we have discussed yesterday. We had discussed two sorting techniques yesterday. So today we will try to cover another three sorting techniques. First, I would like to discuss about bubble sort. Then we'll discuss about quick sort, and then I will give the algorithm how actually the match sort works. Okay, these three things we are going to discuss in the today's class. Now, first, we talk about bubble sort. It is another sorting technique where the repetitive comparisons are involved in this, and the smallest element will be bubbled up to the top. Either the smallest element will be bubbled up to the top, or the largest element will be bubbled to the bottom there. Okay, so it is also called as an exchange sort. So just give me confirmation whether the screen is visible or not.
Yes, sir.
Okay, thank you, Ma.
Yes, sir.
Yes, the bubble sort also, which is also called as an exchange sort here, it involves the repeated comparisons. And the smallest element is bubbled up to the top. The smallest element will be coming to the top. So how actually it is going to work, let me explain you with this example here. See, in either way you can do, either you can bring the largest element to the end or the smallest element to the beginning. In either way you can do. So in this example here, the largest element is actually bubbled up, is moved to the last here. See, first what happens here is between 98 and 23, the comparison is done. So when you do when you do the comparison between 98 and 23, because 23 is smaller, those two are being swapped, and the next iteration, so these two elements are being swapped. Now see here, 23 and 98 are being swapped. So if you observe, initially it is like this, 98 and 23. So first these two are being compared, and then 23 is, and 98 will be swapped, and the 98 is moved to the second position. Okay, next again 98 and 48 are compared, and in this again 98 and 48 are swapped, and 98 moved up to the next position. In the next iteration, sorry, 98 and 98 and 14 are being compared. So then again the 98 is swapped and it is moved to the next position. In the next iteration, the 98 and 6 are being compared, and again 98 is moved to the next position. Okay, again the 98 and 67 are compared, and again 98 is moved to the next position. And then 98 and 33 are compared, and again they have been swapped, and 98 is moved to the seventh position. And finally 98 and 42 are compared, and 98 is moved to the next position, the eighth position. So by this time the largest element will be moved to the means further place there. This is about the first iteration there. In the second iteration, what happens is again it is started from the beginning. So 98 is left and it starts again here. 23 and 48 are compared because 23 is smaller, 48 those are in sorted order. It is not in means in the swapping is not done. Then again 48 and 14 are compared because 48 is larger than 14. Again those two are been swapped, and 48 and 14 is placed in the second position and 48 is placed in the third position. Okay, next again 48 and 6 are compared, and these two again because 48 is greater than 6, again they have been swapped, and 48 is moved to the next position. Again 48 and 67, see already those are been in the same sorted order. So 48 is smaller. So next is 67 and 33 are compared. And 67, after comparing 67, 33, so 67 because it is larger, those have been swapped and it is moved to the next position. Then again 67 and 42 are compared, and because 67 is larger, it is moved to the next position. And by this time, by the second bubble up, see if you observe the top heading, that the second bubble up, the 67 is coming to the top there. Okay. Then next again it goes to the third bubble. Again 23 and 14 are compared. The same procedure is continued. 14 and 23 are swapped. Again 23 and 6. These two are swapped. And again 23 and 45. No need of swapping here. Again 48 and 33. They need to be swapped. So 33 and 45 are swapped. Again 45 and 42. Again need swapping. And here from now no need of swapping because it is the end of the third bubble. Okay, and last three elements are in the sorted order. Again it goes to the fourth bubble. The same procedure is continued. 6 and 14 are swapped. 14 and 6 are swapped there. Again 14, 23 in the sorted position. 23 and 33 are in the sorted position, and 33 and 42 are also in the sorted position. So it is finished. Fifth bubble, no need of swapping. So already it will check for the confirmation, and by this time, okay, all the elements are being swapped here. This is what is the procedure. This is one way here. So in our program actually, which I have given you in the material, what we have done here is we have done in some reverse way. The meaning means, what is that reverse way in the sense here is, for instance, what we have done here is, now if you have an array like this, assume that we have elements of 12, 15, 4, 5, 8, 2, 1, 45, 7, 3. Now here we will come from the end here. So 3 and 7 are compared here. 3 and 7 are compared, and because 3 is smaller, now it is, those two are swapped. So 3 comes here and 7 goes here. Again 3 and 45 are compared because 3 is smaller. So 45 will be coming here and 3 will be going here. Same reverse way, and 1 and 3 are compared. Again these are in order. 1 and 2 are compared because 1 is smaller, 1 is brought here, and 2 is moved here. 2. Then 1 and 8 are compared because it is smaller, 1 is brought here, and 8 is 8 is moved here. Again 1 and 5 and 1 are compared. 1 is brought here, 5 is moved here. 1 and 4 are compared. Again those are in swapped. Again 1 and 16 are compared. 16 is moved here, and finally 1 and 12 are compared. So 12 is moved here. This is the first iteration. Again it starts from here. The second iteration, 45 and 7 are compared. Again these are swapped in the reverse way. Means in the animated PPT which I have shown here, in this the larger element is going to the rear end, whereas in this example the smallest element is coming to the front end. But either way, whatever you are doing, for the final motive here is we are arranging the elements in the sorted order. Okay, so that is about the bubble sort here. So you can like we have done yesterday, because I'm leaving this code execution as an exam assignment for you. So what you do here is you take some array, then you see how the I and j values are changing and how the elements are moving from smaller end to the larger end. Okay, got it? So just take it as an assignment for you. Just like yesterday in the selection sort and insertion sort, where we had taken the I value, j value, and we have seen how the elements are moving from one position to another position. So you do it and come back to me if you have any problem in understanding the code. I will clarify it in the next class. Is it okay for you? Understood?
Yes, sir.
Okay, ma? Okay.
Yes, sir.
Thank you. Thank you. Very good. So next is about uh, another very important technique which we are going to discuss is about the quick sort. So QuickSort is actually working on the idea of a partition here, idea of divide and conquer here. So build on the idea of a partition, the general procedure is to select a value and then partition the array into two sections such that all the elements greater than or equal to the partition value are put one side and all those values less than or equal to uh, uh, less than the value are put to the other side. This procedure is continued for each remaining section until the array is sorted. So what does it mean here? What is the meaning of that? So in this, what we are going to do is we are going to take a value. We are going to select a value. And basing upon selection of a value, what we are going to do here is uh, uh, you are going to divide the entire array into two sections in such that all the values less than the selected value will come to the one side and all the values which are greater than or equal to the selected value are coming to the next side. Okay, and the same procedure is continued. How? I will explain you with an example. See, in two ways. Today, we are going to do this in two ways. While explaining, I will select the value, the beginning value I'm going to select, the first value. And in explanation of the code, I will take the middlemost value and I will explain you. Both are same actually. Eight. Assume this is 17. Oh, okay, fine. So now these are the indexes. At the top, we are having the indexes here. Now, see what you have to do here is listen this very carefully. Now, I am selecting at the beginning value. There is not compulsion that you have to select the only the beginning value as your target value here. You can take the middlemost value also. So that's what I'm saying, that while explaining the code, I will take the target value as the middlemost value and I will explain you. But here, when explaining, I will take the first value here. So from this direction, select the least value, then 12. So in the beginning, 3 is the least value. 3 is the least value. When you are going from this direction, so you come across with 3, the least value, then L. So what you do here is you swap these two. What you need to do here is swap these two. Means after swapping, so 12 comes here and 3 comes here. Okay, now the next what you have to do here is in the reverse direction, you look for a value which is greater than 12 in this direction. So 16 is greater than 12. 16 is greater than 12. Now you swap 16 and 12 here. Swap 16 and 12. So 12 comes here and 16 comes here. And again, you go in this direction. You look for a value which is smaller than 12. So 16 is greater, 17 is greater, 14 is greater, 1 is smaller. Now what you have to do here is you need to swap 1 and 12 there. You need to swap 1 and 12. Okay. Now swapping 1 and 12, the array will change like this. 1 comes here, 12 goes here. Okay. Now, in the next iteration, what you have to do here is to go in this direction and look for the value which is greater than 12. You see, sorry, which is greater than 12. Now, if you observe here, there, 3 is smaller, 1 is smaller, 4 is smaller, 5 is smaller, 8 is smaller, 2 is smaller. Okay, so all the values less than 12 are one side, and all the values greater than 12 are on this side. Right, understood. Now the position of 12 is this one. Now it is fixed. Now what you have to do here is you need to apply the same technique to the left portion of this array by taking 3 as the target element and looking greater value than 3, lesser value than 3, means smaller value than 3, lesser value than 3, like that. And for these two elements, again you need to apply the same procedure. Okay, means మనం ఇక్కడ ఏం చేసామంటే ఒకసారి మళ్ళీ బిగినింగ్కి వెళ్తే మనం స్టార్టింగ్లో అరే పొజిషన్ ఇలా ఉంది. సో మనం 12 టార్గెట్ ఎలిమెంట్ని తీసుకుని 12 కన్నా ఫస్ట్ వాల్యూ చిన్నది ఏమొస్తుందో చూసి దాన్ని మనం 12తో స్వాప్ చేసాం. సో 3 చిన్నది కాబట్టి 3 బిగినింగ్లో పెట్టామండి, 12 ఎండింగ్లో పెట్టామండి. మళ్ళీ ఈ రివర్స్ డైరెక్షన్లో మనం ఇందాక మనం రైట్ టు లెఫ్ట్ వచ్చాం, ఇప్పుడు లెఫ్ట్ టు రైట్ వెళ్తున్నప్పుడు 12 కన్నా పెద్ద వాల్యూ ఏంటి అనేది చూడాలండి. సో 16 పెద్దది కాబట్టి మనం 12ని 16ని స్వాప్ చేసామండి. మళ్ళీ ఏం చేస్తాం, మళ్ళీ రైట్ టు లెఫ్ట్ వస్తూ 12 కన్నా చిన్న వాల్యూ ఏంటి అన్నది చూసాం. 1 చిన్నది కాబట్టి మనం 1ని 12ని స్వాప్ చేయగా 1 ఇక్కడికి వచ్చింది, 12 ఇక్కడ. మళ్ళీ 12 కన్నా పెద్దది ఏంటి అన్నది చూసాం, పెద్దది ఏం లేదు. ఇటు నుంచి చూస్తే 12 కన్నా చిన్నది ఏం లేదు. అంటే 12 కన్నా పెద్ద వాల్యూస్ అన్ని కూడా రైట్ సైడ్ వచ్చేసినాయి, 12 కన్నా చిన్న వాల్యూస్ అన్ని కూడా లెఫ్ట్ సైడ్ వచ్చేసినాయి. ఇప్పుడు మనం ఏం చేయాలంటే ఈ పోర్షన్ని మళ్ళీ సేమ్ ప్రొసీజర్ మనం అప్లై చేయాలి. అండ్ అంటే మనం 3 టార్గెట్ ఎలిమెంట్ అనుకుని 3 కన్నా చిన్నది చూడాలి, స్వాప్ చేయాలి. తర్వాత ఇటు నుంచి వెళ్తూ 3 కన్నా పెద్దది చూడాలి. ఓకే, లైక్ సో చేద్దాం ఒకసారి. సో ఈ పోర్షన్ని కూడా సేమ్ మనం అలాగే అప్లై చేయాలి. సో ఫర్ ఎగ్జాంపుల్, ఇఫ్ యు ఆర్ గోయింగ్ టు దిస్ particular half. Now if I'm going for this particular half now, so what is the value which is lesser than 3? Because 2 is smaller, so put 2 here and put 3 here. Okay, and what is the element which is greater than 3? 4 is greater than 3, so put 3 here and 4 here. So what is smaller than 3? Nothing is there. What is greater than 3? Nothing is. So position of 3 is this one. Okay, now you apply the same thing, the same procedure to these two elements, and you apply the same thing to this half using recursion. We will see that. So the recursion is used here. Like the time, so we are continuously applying. By the time all the elements will be coming into the sorted order. So this is what is the quick sort. Okay, so any doubt? Those who have listened, any doubt? Am I audible?
Yes, sir. No doubt.
Yes, sir.
Okay, you understood now?
Yes, sir.
Okay, Amma. Now let us see the code. See, the code is somewhat complicated, which we are discussing. So be attentive, and also if I am going wrong anywhere, immediately you unmute yourself and tell me, because it is somewhat lengthier code. We need to concentrate very, very carefully here. Now assume that we have an array of 10 elements, array of 10 elements. Assume that we are having values 10, 10, 15, 5. Okay, so let us assume that these are the values. So the indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the indexes. Now this is an array. Now no. Now assume that I'm passing array. So this is array A. I'm passing array to QuickSort algorithm. So int A is an array, and n is actually 10 because number of elements are 10. N is equals to 10. Okay. Then again, what I am doing here is I am calling QS of. So again, it is calling QS of A comma 0 comma n minus 1. N minus 1 means 9. A comma 0 comma n minus 1. So this function, the QuickSort algorithm, QuickSort function is calling again QS of int A, int left and int right. Okay. Now when it is the case, now left is equals to 0. Left will take the value 0. Right will take 9. Okay. Right will take 9. So we have int I, j, n. We have int I, j, n. Then we have I is equals to left, so which is 0. Again, j is equals to right. So j contains 9. Now n is equals to here and another n. N is equals to a of left plus right by 2. A of left plus right. What is left? 0. Right is 9. 0 plus 9 by 2 is 4.5, which is 4. So what is there in A of 4? 5. In A of 4, we have 5. So our target element now is 5. So in the previous explanation, I just took 12 as the beginning element as the target element, and then I have made the changes. Now the target element is taken as the middlemost value here. So n is equals to 5. Okay. See, this n is different. This n is different, and this n is different. This is the number of elements. Okay, that is in that function. Now this n is different here. Okay, so just I'm removing it to avoid confusion. So n is equals to 5. This is n is nothing but a of left plus right by 2. Now I'm accessing the element in the array here. Okay, by 2. So which is 5. Right. Now do. Now this is the while loop. Do while a of I less than number and I less than right I plus plus. So what is a of I? A of 0. A of 0. 10 less than number. Wait. No. This is actually 0 number. I'm sorry. Take it as number. This is number. Okay. So a of I less than number and I less than 8. So what is a of I? 10 less than 9. 10 less than 5 is false. Okay. 10 less than 5 is false. So because 5 it is false, you can directly come to this next here. Because AND condition is because the AND condition is given, both conditions has to be right. If either one condition is false, the entire condition is false. So then you come to this while loop. While number less than a of j. So what is number 5? 5 less than a of j, a of 9, 3. So 5 less than 3. It is also false. Okay. Then I less than or equal to j. So it comes to here. I less than or equal to j. Okay. I less than or equal to j. True. True. I less than or equal to j is true. Then temp is equals to a of I. So we are just swapping. So I'm not. We are just swapping means ij values. The ij values are been swapping. Ante I mean to say a of 0 and a of 9 are been swapped. So 10 and 3 are swapped. So 3 comes here. 10 is going here. Okay, then in this only we are doing I plus plus. I becomes 1 and j minus minus, j becomes 8. And again, while I less than or equal to j, because 1 is less than or equal to j, you will go back. Understood or not? What I have done?
Yes, sir.
Yes, sir.
Okay. Now,
Okay, sir.
okay. Then again, do while a of I less than number. Now what is a of I? A of 1. 2 less than 5 is true. See, 2 less than 5 is true and I less than right. So 1 less than 9, both are 2. Then what I have to do? I plus plus. I have to do I plus plus. So I becomes 2. Again, go back. A of 2 less than number. What is A of 2? 12. 12 less than 5. It is false. 12 less than 5 is false. Now it comes to here. Number less than a of j. So what is number 5? 5 less than a of 8. So 5 less than 4 is also false. 5 less than 4 is also false. Then what I have to do? So this j minus is not performed. So I less than or equal to j. This condition is true. Then the numbers in the positions 2 and 8 are swapped. So what is there in 2? 12. What is there in 8? 4. 12 and 4 are swapped. So here comes 4, here comes 12. Then I'm doing I plus plus, so I becomes 3, j minus minus, j becomes 7. Again go back, while I is less than or equal to j, still it is true, the condition holds true, go back, do while a of I less than number. So what is a of I now? A of 3, 14, 14 less than number is false, 14 less than 5 is false, no. Number less than a of j, what is there in the number? 5, a of j, 19, 5 less than 19 is true, 5 less than 19 is true, and j less than j greater than left, so j is greater than left, 7 greater than 0 is true, then j minus minus, so j becomes 6. Again go back, while number less than a of j, what is there in number? 5, 5 less than a of 6, 5 less than 6 is also true. Okay, 5 less than 6 is also true, and j is greater than left, true. Again j minus minus, it becomes 5. Okay, again number less than a of j. What is there? Number is 5. A of j, a of 5 is 7. 5 less than 7 is also true. 5 less than 7 is also true. Okay, then j greater than left. So 5 greater than 0 is also true. Then again, j minus minus, j becomes 4. J becomes 4. Okay, then again, a of j, sorry, number less than a of j, a of 4, sorry, number is 5, a of 4 is 5. 5 less than 5 is false. 5 less than 5 is false. Now it comes here. So I less than or equal to j, 3 less than or equal to 4 is true. Then I have to swap the numbers at the positions 3 and 4. Means 14 and 5 are swapped. So 5 is coming here, 14 is going here. And again, I plus plus, I becomes 4, j minus minus, j becomes 3. Now it comes here, while I less than or equal to j. See, 4 less than 3, 4 less than or equal to 3. Now the condition fails here. The condition fails. Now the do loop is broken, and now it comes to, the control comes to here. The control comes here. So before going further, if you might have observed, we chosen the target element as 5. Target element as 5. So if you observe, all the numbers less than 5 are in the left position, and all the numbers which are greater than 5 are in this on the right position, if you might have observed. So after doing this, all the numbers which are at the less than 5 are in the left half, and all the numbers which are greater than 5 are in the right half there. Okay, so it is done. Now say again what we are doing here now. So this is done, means the position of 5 is fixed now. Now next what I have to do is, I'm using the recursion. You observe the, you knew the recursion. What is recursion? We have discussed earlier. Recursion is the process of calling a function by itself. Means if a statement in a body of the function is calling itself, then it is called as a recursion. So again, if left is less than j, what is left? 0. 0 less than 3 is true. Then what I'm doing, again I'm calling the function now, qs of a comma, what is left here? 0. What is j? J is 3. Means the same procedure now is applied. The same procedure is applied to 0 to third element. 0 to third element. Okay, and also if right is greater than I, what is right? 9. 9 greater than I, 4 is true. Then again I'm calling qs of a comma, I is 4 comma, right is 9. Means for the remaining these elements, the same procedure is applied. In the sense, if you go to the beginning, see here qs of 0 comma 9. Now for this now what happens here is, left value will be 0, right value will be 9, and for this function call, left value will be 4, right value will be 9, and now the same procedure is applied. So this is done separately, and this is done separately, and the same procedure, the recursively the function is called until all the elements comes under sorted order. Okay, so understood?
Sir, here left equal to 0 and right equal to 9 you have written. As per the QS, it is 0, 3, no sir?
Yes. That is actually the function call. The first function call here, what you need to observe here is, see, I will do one thing. QS of 0 comma, this is the first function call, initial function call. Okay, a comma 0 comma 1. After doing certain position means after doing certain iterations, what we are doing here is again this function. See, recursion, if you might have also remember the examples which you have discussed. Again, this function after performing some iteration is calling this one. And also, this function is again internally calling this one. Okay. Now here in this function call, left becomes 0 and right becomes 3. In this function call, left becomes 4 and right becomes 9. And further, if you work out more, further this may call another time. Okay. And there the left and right values may change. And again, this also may call internally again. It may call the values again. And similarly, the left and right values may be changed. Got it? Hello?
Yes, sir. Yes, sir.
Yeah. So understood, everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So see, as I told you yesterday, what you have to do here is compulsorily you need to take a function. You need to take an array and you need to work on this. So I can't show you all the iterations here. I just initially showed you. You just do for some more. What you do here is you take this a of 4 comma 9 and you try to work out in 4 comma 9. Again, you will take the pivot element as 14 and you will see whether all the elements which are lesser than 14 are coming to one side or not, or all the elements which are greater than 14 are coming to the other side or not. So like that, if you apply, then the elements will be in the sorted order. Got it?
Okay, sir.
Yes,
Okay.
sir.
Okay. So that is about the QuickSort. That is about the QuickSort. Next, let us discuss the final one today. That is MergeSort. See, before continuing, I will just give you the idea about the MergeSort, how it is going to work. So it is an assignment for you. You can take 3 or 4 days and you develop the program for the MergeSort and you submit to me. Okay, not in the group. You can personally submit to me. Just you develop a C program with the MergeSort. Okay, think about that. You can see, of course, if I avoid you also, you will Google out and you'll see. But again, even though if you're searching in the Google, just work on that example and then work on the code and then you submit to me. Okay. Now I will just tell you the idea about how actually the MergeSort works. MergeSort works. Now in the MergeSort, it completely works on the idea of divide and conquer. Divide and conquer. So before going to MergeSort, to explain you MergeSort, so what I am going to do here is I would like to explain you the concept of merging actually. First, I would like to explain you the concept of merging. What actually is merging here? So, for suppose assume that means merging in the sense you know that you are going to combine. You are going to combine two things here. So, for suppose there are two sorted arrays like this: 2, 5, 9, 15, 12, and then you have another array, some 4, 6, 8, 12, 13, and 14. If you observe, now assume that this one is one array and this one is another array. Say they need not be of in the same size. Don't think that SAR has taken the same size elements. Okay, you will take different size elements here. So for example, now if I say 16, Now I just want to merge these two sorted arrays. So the first array is actually contains how many elements? It contains 1, 2, 3, 4, 5, 6 elements. The second array contains 5 elements. So if I merge an array, if I merge these two arrays, I will get an array which is of size 11, an array of size 11 elements. Now while merging, what I will do is I will compare the first two elements, 2 and 4. So because 2 is smaller, I will put 2 first. Then I will compare 4 and 5. Because 4 is smaller, I will put 4 again. Then I will compare 5 and 6. 5 is smaller, I will put 5. Then I will compare 6 and 9. Because 6 is smaller, I will put 6. Then I will compare 9 and 8. Because 8 is smaller, I will put 8. Then I will compare 9 and 13. Because 9 is smaller, I will put 9. Then I will compare 15 and 13. 13 is smaller, I'll put 13. Then I will compare 15 and 14. 14 is smaller, I'll put 14. Sorry. This is actually not in sorted order. Now assume that it is 10. I'm sorry, 10. Where I have to come? Okay, 8 and 9. So 8 is smaller, we have kept 8. Then I compare 8 and 9. Because 8 is smaller, I put 8. Then I compare 9 and 13. Because 9 is smaller, I kept 9. Then I compare 10 and 13. Because 10 is smaller, I'll put 10. Then I'll compare 12 and 13. Because 12 is smaller, I'll put 12. Then I'll compare 16 and 13. 13 is smaller, I'll put 13. Then I'll compare 16 and 14. 14 is smaller, I'll put 14. Then I'll compare, so 16 is left and it is placed there. So once again, I will repeat. Just see here, I will compare the respective elements. I will start with the first elements, 2 and 4. I'm just merging these two arrays, already sorted arrays, and I am making a bigger array here. So 2 and 4 are compared because 2 is smaller, 2 is placed in the first position, 0 index. Then 2 and 6 are compared. 5 and 4 are compared because 4 is smaller, 4 is placed. Then 5 and 6 are compared, 5 is smaller, 5 is kept. Again, 9 and 6 are compared, 6 is smaller, 6 is kept. 9 and 8 are compared because 8 is smaller, 8 is kept. 9 and 13 are compared, 9 is smaller, 9 is placed. 10 and 13 are compared, 10 is smaller, 10 is placed. Then 12 and 13 is compared, 12 is smaller, 12 is placed. Then 16 and 13 are compared, 13 will be placed. Then 16, 14 are compared, 14 is placed, and finally 16 will be placed. So this is actually the concept of merging. Okay, understood this point?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay, now the same
sir.
idea,
Yes, sir.
the same idea is now applied to this array. What we are going to do here in case of this particular MergeSort here is we are going to divide the array into two halves. So 3, 2, 4, 5 as one array. Then again 14, 7, 6, 19 as one array. Then again you divide 3 and 2 as one array. And you divide 4 and 5 as one array. Then you divide 14 and 7 as one array. Then you divide 6 and 19 as one array. Okay. Then you divide individually. 3, 2, 4, 5, 14, 7, 6, 19. Means you consider now each array is of size only 1. Each array is of size 1. Now what we are going to do here is what we are going to do here is we are going to match these two. This one and this one. Considering these two elements as an individual arrays, we are going to match. So when I match these two, then the order will be 2 and 3. 2 and 3. Then you match 4 and 5. So because already they are in order, 4 and 5. Then you match 7 and 14. 7, 14. Then you match 6 and 9. 6, 19. And again, in the next iteration, what you do here is, you think 2 and 3 as one array, 4 and 5 as one array, and now you match these array now. So when you are matching 2, 3, 4, 5, then if you match 7 and 14 as one array, 16 and 19 as one array, now you match these two, like earlier procedure. So 6, 7, 14, 19 means how you are done. So you have compared 6 and 7, sorry, 7 and 6, which is smaller, 6 is smaller, which is placed. Then you compared 7 and 19. So because 7 is smaller, 7 is placed. Then again 14 and 19 are, you have compared, 14 is smaller, 14 is placed, 19. Now, if you observe 2, 3, 4, 5 are in order, 6, 7, 14, 19 is order. Again, you match these 10. So when you are merging, of course, these are in the order, then you have 2, 4, 5, 2, 3, 4, 5, 6, 7, 14, 19. Got it. So what we are doing here is, we are actually here we are dividing it. Okay. Then again these are in divided. Then you match 23 and 98. Okay. Then 14, 45 and 14 are divided. You match these two. These are been matched. Because the entire array is divided into such that each element is of one array, then you are matching. Then you match these 4, 23, 14, 14, 23, 45 and 98. Now apply the same thing to this right half also. 6 and 17 is divided. 33 and 42 are divided. Again, match them. Now you match these two. Got it? I hope you understood now very clearly with this diagram. So once if I go to the beginning.
Yes, sir.
Yeah. So 2 halves it is divided. Again it is divided. Again divided. These are been merged. Again 45 and 14 are divided. Those are been merged. So these 4 are merged now. It is applied to the right half. Now you match the entire arrays. I don't think that we have to take even numbers only and then we have to go for, though if you take the odd numbers also, the matching can be done. Okay, don't think, because it is convenient for us, we are taking the even number of elements there and we are showing you here. Even if it is odd numbers also, then it is going to be done. So divide the sorted unsorted collection into 2 until the subarrays only contain 1 element. Then match the sub-problem solutions together. Got it? That is what is about the MergeSort. Clear?
Yes, sir.
Okay.
Clear, sir.
Yes,
Okay.
sir.
Thank you. So for this, I request you people to develop some code by even looking in the Google and try to develop the code, and you can submit me later on. Okay, ma? So that is about
Okay, sir. Okay, sir.
the merging here.